Okay, let me take this question. It's telling there's a composite rod. So area of cross section, I think he has given. So let me start with the diagram. Same material, but cross section area of segment OB is twice of OA. Again, they're lying on the smooth table. I'll start with a diagram like this. And just for our understanding purpose, I am taking the diagram. Okay, this is kept on smooth table. Both segments are of made of same, but cross section area of segment O is twice of that one. Both are having length L each. Area you call this is A, this is 2A. So what do you expect the mass of them? If this is having a mass M, what will be the mass of this? 2M. Fine. The way the center of mass of this system will be should be on the right hand side. So here there's a center of mass of system. It should not shift. Center of mass of system. So this is L by 2, L by 2. So somewhere it will come here. So now I'll write the temperature. There's a temperature T1 degrees Celsius. So what should happen? So now it's asking, calculate the x coordinate of the joint if quotient of linear thermal expansion of the material is this one. So the joint is here. So let's take the joint sum. This was a joint. No, now the joint will shift. Okay, we'll take the situation like this. So the joint will shift here. So this will be center of mass will not shift. So the joint in fact will shift. Are you seeing that brown color line? I'm showing the shift in this joint. The joint will shift towards left here. So the center of mass C1, so it will take the new position. The center of mass of this. Okay, this should be. Okay, let it be something. I'll bring it here. Okay, let's get into the idea. So this is what? Center of mass of system. It should not change, that we know it. So what was earlier the distance? So this will be how much length will be? L by 2. So at what distance the center of mass of this will be? L by 2. So center of mass of system should not shift, no? M1 x1 should be equal to M2 x2. Center of mass of system should not change, but individual center of mass, they'll undergo displacement. Are you looking at this dot? Brown color is what I'm showing it for. And X is the displacement of the joint. So what is X? We'll write it. X is displacement of joint. Okay, let's write equation. M into straight away the displacement of the center of mass of the lighter of the thinner rod. There should be X plus L by 2 alpha delta theta. 2m. Due to thermal expansion, it will shift towards right. But due to shift in joint, it will be towards left here. Solving this will get expression for X. So from where this is equation brought? Anybody wants to answer? So what you should write? Displacement of what is this quantity? Displacement of center of mass of left rod. What is this quantity? Displacement of center of mass of right rod. Solving this will get expression for X. X will be L alpha delta theta by 6. Joint displacement of joint. Already I written, no? Center of mass of system will not undergo that. That's why I'm writing M1 x1 equal to M2 x2. Or M1 delta x1 equal to M2 delta x1. What is delta x1 delta x2? Displacement of center of mass. Here what happened? The length here, this will expand and also joint will move. So therefore I should take this one. Here this will expand and the joint will shift towards left. No, that's why negative sign. So I should write center of mass of system of will not shift. So there's a topic where it will be mixed with all other ideas. I'll come to this later on. I think we have plenty of questions. Let me use thermal stress for the LR rod. No? So stress, can you remember stress something elasticity? So we define like this, no? Young's modulus equal to stress by strain. So here I'm going to introduce the thermal stress. So let's have if there's a rod. It's having a length L. Young's modulus Y, area of cross section A. Let the temperature be theta 1 degree Celsius. I'll increase the temperature. What will happen to the rod? The rod will expand. So now how much length? L plus delta L. Will there be any stress in the rod? No stress in the rod. Any reason for that? Because it is at natural length, no? At what is the length? What is you can write this? What is L? Length of the rod at theta 1 degree Celsius. It's at natural length at theta 1 degree Celsius. What about the rod now? L plus delta L. It is a natural length of the rod at theta 2 degree Celsius. So when the rod is at natural length, no stress will come. Sir, we are not understanding. You take simple spring. If the spring is at natural length, will there be any spring force? If spring is at natural length, will there be any spring force in it? No spring force. If there's no force, no question of stress. Getting the logic? This one. So will there be any stress in the rod? No stress in the rod. Similarly, here also, no stress in the rod. Getting the idea? Okay, now I will increase temperature, but I will not permit it to expand. Let's take the question here like this. So there's a rod. Length of the rod is L. Young's modulus A, temperature theta 1 degrees Celsius. I will increase the temperature. So what the rod? It wants to expand, no? But do I permit it to expand? So here, let's assume that I'll increase the temperature. So what will happen to the rod? The rod actually wants to expand. Fine. So this is the length L. So here is what? The elongation. But what happened here? I will not permit it to expand at higher temperature. I'm trying to explain the concept. You have to really catch this. So what is the length of the rod? Is L. What is the temperature? Theta 2 degrees Celsius. At theta 1 degrees Celsius, what was the length of the rod? L. At theta 2 degrees Celsius, so what do you expect the length of the rod? Should be more than L, no? And this will be elongation. So how much elongation here? Delta L by 2. Delta L by 2. But what we are doing, we are not permitted to expand. So how much shall I say, what is the state of rod? At theta 1, it's in natural length. Rod in natural length. So when the body is at natural length, so no stress will be there. Now I'll rise the temperature. What should be the length of the body? So no, this is a natural length. Okay, no stress. So definitely what you can write? No stress, no strain. Therefore, no strain and no stress. Similarly, for same thing, this also. What is the condition? We can write it as no strain and no stress. Okay, now come for this one. What should be the length of this rod? Should be L plus delta L, no? But how much it is compressed? By an amount delta L. So shall I say that it is being compressed? Who is compressing? Being compressed. Tell me who is compressing it? The wall. The walls will not permit. The wall will not permit it to expand. So it is being compressed here. How much it is being compressed? By an amount delta L. You have to understand the method here. Finish. You can do very things easily here. So it is being compressed. So therefore, what happened here now? It is being compressed. So shall I say, or being stressed. So I want that thermal stress here. That has to be calculated. So what is the change in temperature? Delta theta. Okay, let's come for this one. So delta L should be equal to L alpha delta theta. So what do you mean by thermal strain? Delta L by L should be equal to alpha delta theta. We know stress Young's modulus equal to stress by strain. So what is the strain? Alpha delta theta. So sigma equal to y alpha delta theta. This is called like a thermal stress. So what actually the rod wants to expand, but the wall will not permit. So how much of stress is generated? This much here. So y alpha delta theta. What do you mean by sigma? Sigma should be F by So therefore, what is further F is equal to sigma into it. What is sigma? Y alpha delta theta. Delta theta is change in temperature. Please, no rotation, nothing. Y alpha delta theta is change in delta theta is change in temperature. What is F? F is the force set up in the rod. So we will set a force on one side. The wall will exert force like this. In turn, what will happen? The rod will exert force on the wall. This force per unit area will become stress. If there were no walls, the rod will expand. It is at natural length. So when a body is at natural length, no stress will be there. So are you getting? No? So okay. Now you can ask questions. Sir, you increase temperature. I'll decrease temperature. Tell me, if you decrease temperature, what should happen to length of the rod? Should become less than L. But the rod will not permit. The walls will not permit. Then what will happen? The rod is in what, like elongated state. Then the forces will be in opposite direction. So now, if the rod is at natural length connected between two rigid walls, if we increase or decrease temperature, what will happen to stress in the rod? Will become non-zero because the wall will not permit it to be at its natural length. Able to understand the concept here, why the stress will come. So what you have to, in all such numericals, what you have to search, is it at its natural length? Based on that, what happened, we should decide here. So how much of energy is present in this? So the energy present, elastic potential energy is stored. So we know stress is squared by 2y. Y alpha delta theta. So if you solve this further, you'll get the energy stored in the rod. Simplest thing, elastic potential is stored in the rod. So what is delta theta? Change in temperature. Tomorrow we'll take few more better examples. Let me go for one more idea related to this. Okay, this is called like a bimetallic strip. See, so now everyone knows thermal expansion formula, but the diagrams, the conditions given, physical conditions, those things should be understood properly. So we have a bimetallic strip. Instead of I will do welding for these two things. So there's a material of length alpha 1, alpha 2. They are welded. I will rise the temperature. So what do you expect? If they are not welded, they will expand. So if they are not welded, no, suppose that these are the two rods. Yeah, let it be. So if I increase temperature, if they're not welded, just they are in joint, no, so they will expand naturally. T2 greater than T1. When do this will happen? If they're not welded. Huh? No, if I do welding on them. So what do you mean by, sir, welding? So that they are, I'll take some fabric. These are not rods. So you can take these plates or anything. Okay, timing. Let me take let me a rod. So these are welded here. Two cylindrical rods. Or sir, what is the area of cross section? It can be what will happen, circular or rectangle. Let it be different. They are welded. Then I'll increase temperature. If I put alpha 1 greater than alpha 2, this wants to expand more, no? Then this will not permit. So when they are welded like this, so when you rise the temperature, so how the shape of the rods will be? The rods, what happen, will bend. Instead of this, if you rise the temperature, the rod and now you have to ask question, sir, why this curvature you are bringing? Any reason for that? The simplest thing is like, since alpha 1 greater than alpha 2. If alpha 2 greater than alpha 1, then it will bend like this. So when they're not welded, this will be thing. So let's have a diagram. If when they're welded, so if alpha 1 greater than alpha 2, if alpha 2 greater than alpha 1, so it will be like this. Now you have to give explanation, sir, why it will happen like this. If alpha 1 greater than alpha 2, this rod wants to expand more, no? So therefore, it will be convex, it will be curvature will be like this here. If alpha 2 more than alpha 1, this wants to expand more, but this will not permit. So therefore, they'll take shape like this here. Getting the idea? So when you rise temperature, this will be a temperature T1 degree Celsius. How the curvature depends upon which one is greater. So let me assume alpha 1 greater than alpha 2. So I'm interested in now few things like, what is the radius of curvature? So due to rise in temperature, so earlier T1 degree Celsius. Now what is the temperature? T2 degrees Celsius. So I want expression for radius of curvature. On what all factors this radius of curvature depends here. This is called like a bimetallic strip. Very useful in applications. Of course, we don't go for application much. What is the question? Find the radius of curvature. Are you seeing any curvature for that? So let R be the radius of curvature. Let the thickness of, okay, then this one, let it be D. Okay, let's get into this one. So what is the length of the rod 1? Length of the rod L1 should be equal to initial length, let's assume L0. So L0 into 1 plus alpha 1 delta theta. And what is this quantity equal to from the diagram? Arc length it should be R plus D into, this is delta T, I'll write it. Then similarly, what is L2 is equal to L0 1 plus alpha 2 delta T should be equal to R theta. What are L1, L2? Length of this part. If you want, you can start with the middle. Let me directly take this one. So this is L2. This is L2 and let this be L1. So let's divide this two. So L1 by L2 should be equal to R plus D theta by R theta. What is L1? What is L2? R plus D by R. No, L0 also gets eliminated. Let me go for binomial expansion. So this will be 1 plus alpha 1 delta theta, alpha 2 delta theta. This is I'll go for one more step. One minus alpha 2 delta theta 1 plus d by r. So that one gets eliminated. Oh, this is, sorry. It should be product of these two, no? Alpha 1, alpha 2, delta theta. What are alpha 1, alpha 2? They'll be very small, negligible. So therefore, I'll end up with the expression d by r. So this radius of curvature, how it is? It is inversely proportional to alpha 1 minus alpha 2 and inversely proportional to change in temperature. If alpha 1 minus alpha 2 is more, r will be less. Fine. If the rise in temperature is more, r will be less. So like that, what happened? How much it will bend? How much it will bend? That depends upon the difference in quotient of linear expansion and the rise in temperature. This will be very troublesome topic for student, because like we have seen simple pendulum, suddenly one two concept, one two formulas, finish out, beyond that nothing will be there. Again this is the thing. Like that when you'll get multiple ideas, there are around 15 to 20 ideas are there with thermal expansion. So in exams, so you should be very careful about, so what we should know. So we should have a better idea about the other topics. Thermal expansion is very simple. Delta L is equal to L alpha delta theta or delta T. It will be how that thermal expansion will be there in that particular system that have to be modified. So there are some questions of this kind related to thermal expansion. Previous problem you have seen something related to some topic. So these are called like a mixed concept. So maximum you get questions of this kind on an exam. Like a mixed concept, or sometimes there's a pure thermal expansion. So there's a bimetallic strip. And now you see this what actually, if they're welded, if they're not welded, it will be off like this. Sir, how do I come to know? I think that is some observation. A student must have observation. If they are not welded, this will expand, this will expand. They're free to expand. If they're welded, this wants to expand more. So this will, what this will do? This will try to oppose. So therefore, it will start bending. So based on alpha 1 greater than alpha 2, based on that, the curvature will take place like this. Okay, we have other questions. I think let's take with one small one. It is,